Okay, the question shows a rectangular coordinate system, and the question goes, which quadrant, if any, contains no point that satisfies the inequality you see here? All right, so that calls for the theory we saw a moment ago, right? How to interpret linear inequalities with two variables. Remember, such inequalities represent semiplanes, either of the two semiplanes forming above or below, a line on the plane. So you can try. So which one? All right. Option 4 or quadrant 4? Yeah, interesting answer, Lorena. It could be
Quadrant
interpreted
4.
quadrant 4. Okay, that's a different answer, not Lorena's. Angelo, thank you. Yeah, but actually, if you meant this for an answer, this is it. Okay? Why? Well, let's go over the steps in the procedure we discussed to deal with linear inequalities with two variables. First, let's focus on this, understanding how this line may be represented, on the xy plane. So the method we have is define graphically the position of the intercepts, that is the points where the line crosses the two axes, right? For the y-intercept, you make x0, so that means y would be precisely positive 3, and when y is made 0, then x would be negative 5. Meaning, you have something like this, okay? If the y-intercept is 3, it means the line crosses, over here. And if the x-intercept is negative 5, it means maybe somewhere near this position. So that means that the line crossing those 2 points will be something like this. So now it's just a matter of defining which of the two semiplanes we are talking about. The one above or the one below. Let's try the next step in the method. This point is clearly the origin below the line, right? So substitute these coordinates in the inequality. 3 times 0 makes 0. Less 5 times 0, that makes 0. So you have this. Is this true? No. This is false. Because 0 can't be less than or equal than any negative number. 0 will always be greater than any negative number. Being the inequality false, when you substitute x and y for 0, that means that the point we're talking about, okay, doesn't make part of the region represented by the inequality, which means then that the region must be the upper one, the upper semiplane, because that semiplane doesn't touch the origin. And that's why this resulted, right? So now that we see here, we interpret the question, which quadrant doesn't contain any points that satisfy this inequality? You see the first quadrant contains point if the semiplane, shaded, right? The second as well. The third also contains point in that semiplane. The only one quadrant that doesn't touch the semiplane at all is the fourth. That's why. Okay?